Alright, tomorrow we have our first test of the year. It's on chapter 1, and this is the review assignment that goes along with it, starting on page 63. Okay, the first section, we are looking at writing algebraic expressions. So we're giving a word phrase, and we are taking the words out and writing it instead, just using math symbols. Okay, so for numbers 10 and 12, that's what we'll be doing. On number 10, it says the sum of a number and x. The sum of a number x and 21. Well, we know that sum means that we're going to add. The sum of a number x and 21 would be x plus 21. So we need to learn those keywords that tell us to add, subtract, multiply, and divide. So for number 10, we're going to have x plus 21. Number 12. For number 12, it says the difference of 3 times a number x and a. Difference means to subtract. 3 times a number. 3 times a number is going to be 3x. Difference of means that we're going to subtract, and we are subtracting 8 from it. So 3x minus 8. This would be the difference of 3 times a number and 8. Moving on to the next section. The next section we're doing the opposite of what we just did. Write a verbal expression for each algebraic expression. So from this section we are doing numbers 14 and 16. Now for this section, your answer might not look exactly like mine. That doesn't mean that one of us is wrong and one of us is right. There are a lot of ways to say each of these. So as long as yours is right, then you're okay. Looking at 14, we have, the way I would read it is 2 times p squared. Now you might say 2 times p squared for 14, or you might say the product of 2 and p squared. So that both options are possible for 14, so I'm just not going to write those. 16, we could read this as 1/2 of x plus 2, or we could say the sum of half a number and 2. Okay, either of those would work. Some others also. Number 18, it says give the next 2 items for each pattern. So we will, from this section, be doing numbers 18 and 20. Alright, looking at 18, we have triangle, square, pentagon, hexagon. So it looks like each time we are adding a side to each polygon. So our next one needs to be a heptagon and then an octagon. Okay, so I'm not going to draw that because it's going to look bad, but I would have a 7-sided figure and then an 8-sided figure to come next. Okay, number 20. We have the pattern 1 1 2 3 5. So 1 1 2 3 5, and the directions say to write the next 2 items in each pattern. Well, we want to see how we get from one term to the next. Okay, this isn't very obvious, but it looks like we would do 1 plus 1 to get 2. And then we would say 1 plus 2 to get 3. 2 plus 3 to get 5. So it looks like we're adding the 2 previous terms to get the next term. With that being said, when you say 3 plus 5 to get 8, and then our next term, 5 plus 8, would give us 13. Alright, looking at our next section, the directions say consider the following sequence: 10, 100, 1000, 10,000. Okay, we're going to do from this section numbers 22 and 24. Give the next 2 terms of the sequence. Well, it looks like in this series you can think of this as adding an extra 0 to each to the previous term, or you can think of this as 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power. So the next 2 terms in the sequence, well, we have 10,000. If we add a 0 to the next term and another 0 to the next term, then for number 22 we're going to have 100,000 for the next term, and then the next term would be 1 million for number 22. Okay, that is 22, and 24 looks like this. What are the 9th and 13th terms? Well, we had 1, 2, 3, 4. This was our 5th term. This was our 6th term. So if we continued it from there, we would have one extra 0, and then another extra 0, and then another extra 0, until we got to our 9th term and our 10th term. Well, it looks like our 6th term has 6 zeros, our 5th term has 5 zeros, so our 9th term is going to have 9 zeros. So a 1 and 9 zeros would go with it. Our 10th is going to have 10 zeros. So 10 zeros come after our first 9. Alright, moving on. We are going through number 32 even, so that was 24. Our next section says evaluate each expression. So number 26 is where we're starting. We have 10 minus 6 divided by 8 for 26. 10 minus 6 divided by 8. Okay, so we don't have any variables that we're substituting values in for. All we are doing is following the order of operations here. We said that we have to simplify inside of grouping symbols first. So 10 minus 6 gives us 4, and then we have 4 divided by 8. Okay, your answer could appear in a couple of different ways. Our answer could be 0.5. Or our answer could appear as 1/2. One of those two should be the answer that we come up with. Alright, looking at 28. Number 28 from that section, we have 0.8. Times 0.02 plus 0.05 in parentheses, and we're subtracting 0.006. Alright, we again don't have any values for variables that we're substituting in. All we need to do is to follow the order of operations, which means we're going to do parentheses first. 0.02 plus 0.05. That gives us 0.07. I'm going to bring down everything that we haven't used, which includes the parentheses, because that tells us that we're multiplying by whatever's right outside of the parentheses. Then we're going to subtract 0.06. At this point, we have multiplication and we have subtraction. If I multiply 0.8 times 0.07, it's going to give us 56. So we're going to have 0.056 minus 0.006. So when we subtract those two, then we are going to get 0.05 as our answer. Alright, number 30. When we get to the next section, we are going to be substituting values in for the different variables. On number 30, we have t squared plus 3y. Okay, we need to remember when we're substituting these values in for the variables, a lot of people follow the rule of inserting each value with parentheses, and that might not be a bad idea. Okay, on number 30, we need to know the values of t and the values of y. I'll find those in the directions. T equals 3, y equals 2. I'm going to write that over here. T equals 3, y equals 2. So I'm going to substitute 3 in for t. So instead of t squared, we have 3 squared. Instead of 3y, we're going to have 3 times 2. Be careful here. When we took our first quiz, a lot of people just substituted the 2 in for the y and treated it as 32. It's 3 times 2. At this point, we need to follow order of operations. 3 squared is what we'll do first because of exponents. And then I'm going to bring down the rest of what we're looking at. Okay, then we have addition, we have multiplication. 3 times 2 gives us 6, and 9 plus 6 gives us our answer of 15 for number 30. Moving down to the next problem, 32, we have ty divided by x. We just said that t is 3, y equals 2, and x we are using 0.1. Okay, again, this means t times y, so when we substitute these values in, treat them as 3 times 2. So instead of ty, we know that t is 3, and we know that y is 2, and we know that x is 0.1. We have multiplication, we have division. Remember, multiplication and division happen at the same time from left to right. So 3 times 2 is 6, and then we have 6 divided by 0.1. And 6 divided by 0.1 is going to give us 60. Okay, so that's number 32. If we move on to the next section, we were looking at 57 through 69 odd. Okay, 57, we have an expression that it tells us to simplify. So we have 3m plus 5m plus 12n minus 4n. Okay, to simplify an expression, the two ways we've looked at doing that are by using the distributive property, if that applies, and then combining like terms. When we look at number 57, we don't have the distributive property because we don't see any parentheses. So all we need to do is to combine like terms. Remember that like terms are any terms that have identical variables and exponents. Okay, so 3m and 5m are like terms. 12n and the minus 4n are like terms. So now if we do the operations that it tells us to here with the like terms, then we'll have our answer in simplest form. 3m plus 5m gives us 8m. 12n minus 4n gives us 8n. So 8m plus 8n would be our answer on 57 in simplest form. Okay, on numbers 59 and 61 and 63, it says name the property illustrated by each statement. Okay, 59, it looks like we have 7 times p plus q and 7 times q plus p. Okay, so one of the properties that we looked at involved switching the order or changing the order of some of the parts of our expression. On number 59 we have p plus q, but then if we look at the right hand side of the equation we have q plus p. So this is the commutative property, but more specifically it's the commutative property of addition, because the two things that we are switching are the parts that are being added. So the commutative property of addition. At number 61, b plus a times c, we have c times b plus a. 61 is kind of tricky. Again, it's obvious that we are switching the order of something. We have b plus a, c, then we have c, b plus a. So we are switching the order of the things that we are multiplying. So our answer to 61 is going to be commutative property of multiplication. And then 63. 63, we're doing the same thing that we did on number 57. We're combining like terms because the directions just say simplify. So on number 63 we have 2x plus 2y plus 3x plus 3y. So if we combine like terms, we know that 2x and 3x are like terms, and 2y and 3y are like terms. 2x plus 3x gives us 5x. 2y plus 3y gives us 5y. So for number 63, our answer is 5x plus 5y. For number 65, the directions say write an algebraic expression for each verbal expression, then simplify, indicating the properties used. So 65 says twice the product of P and Q increased by PQ. So twice the product of P and Q. So if I write the product of P and Q, it looks like this. Then it says twice the product of that. Okay, so if we write that, twice the product of P and Q, then we need to multiply that by 2. Then if we look back at the problem, increased by PQ, so we need to add plus PQ. Alright, so if we write that in simplest form, then 2 times PQ, this can just also be written as 2PQ. Then if we write this in simplest form, it's going to involve us combining like terms. If we add these 2 terms, 2PQ plus PQ, which is the same thing as 1PQ, then we get 3PQ. So this would be our answer in simplest form on number 65. Okay, a couple more problems. Numbers 57 or 67 and 69. 67 is involving a graph. It says match each description with the most appropriate graph. We're looking for the graph that represents an airplane taking off and then landing. Well, we need to pay attention to what our labels on the X and Y axes are. We're looking at rate and time. So we're talking about how fast this plane is moving compared to time. So an airplane taking off, we know, is going to start off slow. It's going to build up its speed, and then it's going to get to its top speed, and then it's going to slow back down. If we look at graph A, it looks like we're starting off fast, but we know our plane isn't going to be starting off fast as it's taking off. It's going to start off at a resting position. So this would just look like the landing of a plane. Graph B, it says that our rate is the same all the way across, that we're traveling the same speed at every moment during a flight. Graph C, though, looks like we're speeding up because our rate is increasing. We're speeding up. We get to a point where we're staying at a constant speed, and then we're slowing back down to a resting position at the end. So for number 67, our answer is going to be graph C. And then number 69. On number 69, there are 3 parts. It says there are 80 calories in 1 serving of skim milk and 8 servings in half a gallon. Write an expression that describes how many calories you get if you drink S servings of skim milk. For A, our answer is going to be 80S. For B, our answer is going to be 320. And for C, our answer is going to be 640. This is for number 69.